I'm going to walk through numbers 13 and 14 from 6.7 Ready, Set, Go. You notice I'm not using the actual worksheet. The reason is I want to use this graph to illustrate to you how and why these methods work. So right now our goal is we want to figure out the slope and the distance between these 2 points here. So first thing I'm going to do is I'm going to graph them, because I'm going to show you how it works on the graph first, and then we can explore how it works using the formula. So you'll notice right here I've graphed everything. -3, -2, as well as my origin right here. Now, I'm trying to find the distance ultimately from here to here. Now I can't exactly do that, I can approximate it, but I can't get an exact distance like this, so I'm going to have to do a little bit of work. First thing I want to do is I'm going to find the slope. So I'm going to notice that I go up 2 and over 3. So up 2 and over 3. So I can identify my slope as 2 over 3. Now, chances are you might be noticing I've created a right triangle here. Now for a right triangle, if you have the two legs, which I do here, 2 and 3, that allows me to solve for my hypotenuse here, c. All I gotta do is plug it into a formula. 2 squared plus 3 squared equals c squared. Again, just using the Pythagorean theorem, a squared plus b squared equals c squared. Do a little bit of math here and you'll get c equals square root of 13. And that is ultimately the distance between these 2 points. Now you notice I did that by creating a triangle. Now you can do this without using a graph, and let me show you. Slope. I know a lot of people like to think rise over run, but ultimately down the road this will help you a bit more. Think of it as change in y over change in x. So what can I do here? I can take my y values, -2 and 0, subtract them. I can also take my x values, -3 and 0, subtract them as well. When I do that, guess what I get for my slope? Same thing I just did. Oops, excuse me. 2 over 3. And now I've got my slope. The slope essentially gives me the side lengths of this triangle, which as you see here, 2 and 3. So I can plug that into the formula right here, and that'll give me my hypotenuse. So now for this next example, we're going to use just the formula here. We're not going to use the graph. So let's see, I'm going to go with my y's here, change in y, which is -1 minus 7, over my x, which is 7 and 11. 7 minus 11. Do this out and I get -8 over -4. It simplifies, if I can cancel out my negatives, make it 8 over 4. You might be tempted to simplify this, but we're going to keep it as it is right now, because it'll preserve our triangle. So now I have my side lengths here. 8 and 4. Just plug this in the Pythagorean theorem. 8 squared plus 4 squared equals c squared. Do a little bit of math here. You get 80 equals c squared. Square root of 80 equals c. So that gives me my distance between these 2 points. What I'm also going to do is this time I did the formula first. I'll show you how it works on the graph so you can see how it works. So I'm going to go to 1, 2, 3, 4, 5, 6, 7, 1, 7, -1. And then I'm going to go to 8, 9, 10, 11, 1, 2, 3, 4, 5, 6, 7. 11, 7. So again, just like last time, I'm trying to find the distance between these 2 points. In order to do that, I'm going to use the slope. We're going to go up 8 over 4. You notice I've created another right triangle, 8, 4. So, again, 8 squared plus 4 squared equals c squared. So hopefully you can see how it works using the formula as well as a graph, because you're going to be dealing with examples where your coordinates are going to be pretty big, and it's not going to really be timely to make a graph out of it. And using this formula will be a lot more easy, I guess you could say, or a lot less time-consuming, rather. So, best of luck, and you know you can always reach out to me with questions.